Good afternoon, everyone. My name is John Miller. As a member of the Board of Directors of Chesapeake Forum, an academy for lifelong learning based in Easton, I am delighted to welcome all of you to our Distinguished Visiting Scholar program. This program is dedicated to the memory of John F. Ford, founder of Chesapeake Forum, teacher, poet, esteemed public servant, beloved friend of many who are in our audience this afternoon. This afternoon is Chesapeake Forum's third annual Distinguished Visiting Scholar. In 2020, Commander B.J. Armstrong of the United States Naval Academy discussed the history of irregular warfare. In 2021, David W. Blight of Yale University spoke about Frederick Douglass in his time and in ours. And this afternoon, I have the pleasure of introducing Pam Conrad, an astrobiologist and planetary scientist. Conrad specializes in understanding how planets do or do not evolve into habitable environments. And she is presently involved in the exploration of Mars with NASA's Perseverance rover and its companion, the Ingenuity helicopter. As an Episcopal priest, Pam's primary responsibility is rector of St. Albans Episcopal Church in Glen Burnie, Maryland. Pam will engage us in a conversation on the topic of exploration, adventure, and science. What is the difference and why does it matter? She has also kindly agreed to take questions from our audience. Please submit your questions to me via the chat function on your laptop. And please welcome our third annual Distinguished Visiting Scholar, Pamela Conrad. Pam, the dais is all yours. Welcome.
Thank you, John, and thank you to the forum for inviting me to join you. Your cause is near and dear to my heart. A friend of mine once said to me about 20 years ago, take a math class and a physics class every year for the rest of your life. I couldn't think of anything more awful at the time. But since then, I'm pleased to say I have tried to follow up on his advice on occasion, but I needed to make room for things like constitutional law and drawing Zentangles and the like. Life is too short to just stick with one topic. I try to use that as my rationale for exploring many different venues for learning. And so I applaud all of you for doing likewise. I'd like to say that we will have an orderly progression through a single topic today. But as per my usual operational style, I just had too many things I wanted to share with you to have it proceed in as orderly a way as one could and explore any one of them in depth. So what I hope to do is offer you a smorgasbord of ideas to prompt you to rethink the role of exploration in your own lives, and in general, the utility of exploration as a societal endeavor. I do have slides. I'm going to try not to have word slides. I'm going to go back and forth between showing you images and opening up your faces to one another in the galleries so that if you want to have discussion, it'll be facilitated. I personally have had a circuitous path to my present bivocational career. I will say that everything I have ever done in my life has turned out really to be related to everything else I do subsequently. And so it gives me a thrill when something that I studied maybe 30 years ago turns up as useful and something that I am doing in the present. So I have no doubt that anything that I learned today might come in handy in another 20 years, should I be so lucky as to still be around then. So the first thing I'm going to do is share my screen. I want to make sure that you all can see it. Now, I have sort of moved all of your squares to a place where it's not convenient to look at it without it looking like I'm gazing off into the distance. So John, if you need to just speak out because either you can't hear me or you can't see something I'm showing, please feel free to just shout that out. I'm also going to open the chat window so that if somebody wants to make a comment, they can do so there. I'm also not averse to you just unmuting your microphones if you have a question. I'd like this to be more of a discussion and less of a lecture so that I can learn from your wisdom. So, item 1, I'm putting this slide here after I promised you I wasn't going to be into words because I want you to have my email address. I'm sure that John will make sure you have it later, but sometimes you don't think of a question until after the fact. It's very easy. It's babeofscience@gmail.com. If you have a question later and you write me, I promise you I'll answer you. I can't promise it'll be within minutes. I try not to be too much enslaved to my iPhone, although it is tempting, but I will answer you. So, on with the exploration. Exploration, adventure, and science are 3 different things. In my title, I asked you what the difference is and why it matters. And I hope that by the end of our time together, you'll have some sense of what that means for you. On the left of your screen, you should see an image that might be familiar to you if you're of a certain vintage, at least of my vintage. It's a Good Humor truck. On the right, you'll see an image that may not be familiar to you unless you've done some Arctic exploration. It's a polar bear. They're both white. They both have a front end that could do you harm, and they could represent an opportunity or threat. Exploration is a biological imperative, and all living things do it. Even plants, things that appear to be sessile, or things that are just unicellular. And actually, I realize that sounds almost demeaning, just unicellular. Unicellular organisms can be very diverse and cosmopolitan. So we need to appreciate them for that and their role in maintaining the entire biosphere of the Earth. But back to the Good Humor truck and the polar bear. For a person unfamiliar with the technology and with the species, these things might apparently be similar. Because they're both white, they have these 4 fangs on the bottom on which they stand or move. If the Good Humor truck rings its bell and you're about 7, it's a fantastic opportunity. You hear it, you run out the door, you beg your mother for a little cash. If you're of the devious mindset, you might go through her purse and just look for it. And the thing about it is, if you run out too fast and into its path, it becomes more threat than opportunity. But it's something that we approach with joy. The polar bear, on my Arctic explorations, has always been seen as a threat. When we're in polar bear territory, that is somewhere where a polar bear has been sighted within a few kilometers, we half load the rifles so that we're ready should we need to defend ourselves. In my Arctic exploration sites, it's illegal to kill a polar bear unless it's charging you and within 100 meters. That presents a challenge because they move so quickly that chances are good you would not be able to fell the polar bear by the time you lifted your rifle, because they can travel so fast. In about 2 seconds, they can cover 100 meters. On the other hand, if you are a wildlife photographer and an appreciative nature enthusiast, the sighting of a polar bear is an amazing opportunity. This one was a wonderful opportunity because I was in a dinghy in a fjord, and I knew that we could speed away under our motor power before he could get to us. So I was excited to see him. The Good Humor truck and the polar bear are a good example of opportunities and threats taken to an absurd level. But in the practical biological sense, that is why every organism explores, so that we can learn about opportunities and threats. threats to avoid, opportunities to exploit. Adventure is what we do to seek thrills. Who doesn't love a good thrill? That's why we try to put our foot on one pedal of the bicycle, our other leg behind us in an arabesque, and balancing as we descend down a hill at a screamingly fast pace. It gives us some sort of thrill. I'm not sure why. As we age, we get a little bit more risk averse, but we still do some things for a thrill. That's why some people have gambling problems, because of the thrill of not knowing whether some good or some disastrous outcome will happen is stimulating. Adventure seeking is not the same as exploration. Thrill seeking is something that's done by choice and for fun. When you see a person and define them as an explorer, they're a person trying to understand new territory, new ideas, new things in general. An adventure seeker is seeking that thrill. One of the other differences between the activities of exploration and adventure seeking is that exploration is something that you can do with very little numbers of resources. Adventure seeking is something that often is expensive and requires somebody else to support it. For example, people who try to set hot air balloon records or ascend very high and dangerous peaks, mountain peaks on the earth. These require fancy equipment, lots of money, and sometimes the adventure seeker has to raise funds to do that. Again, exploration does not require a lot of specialty equipment unless you're going to a specialty environment, and we're going to talk about that shortly. Science is what invests exploration with value. When the public funds scientific exploration, or a private foundation funds scientific exploration, to ensure a return to the funder, we write papers, we distribute the results. We might develop a new technology which is of some benefit to humanity. Exploration seeks to return wisdom to the explorer and others who will benefit from that exploration. And the reason we employ science in the service of exploration is because science is a standardized method that helps us to approach our exploration in such a way that we can reproduce results and we can learn to draw inferences, discuss the biases which may influence our interpretation of what we're learning, and then return that into the literature to the public good. Is exploration always without bias? No. We are pesky, we humans. We have all sorts of ways of bollocksing up our relationships with one another and with wisdom. And so that's why we have to explore broadly so that we can see different approaches to learning new things and evaluate their effectiveness and perhaps their veracity. One of the problems we face now as a species which has enabled itself to have a fire hose of knowledge. Wait, let me say that differently. A fire hose of information assaulting us daily is that we can not always distinguish between useful information and non-useful information, or in fact, truth from fiction. One of the roles of exploration is to teach us not only to think critically, but to employ all of our senses and all of the tools that we have evolved to assist ourselves in bringing that knowledge to a place where we can evaluate its utility. So I hope that you will understand that exploration is not just a tool for your biological survival potential, but also for elevating the level of social discourse, for exploring new ideas, evaluating those new ideas for their potential impact on you, your family, and the society in which you live. I have dedicated myself to exploring not only interesting environments on the earth, but also interesting environments off the Earth. Somebody asked me why I'm not exploring, for example, Jupiter or the moons of Saturn and Jupiter. And what I said was, at the best, it would take 7.5, 8 years to get there. I don't have that kind of time. So I explore Mars because it's close. I'm getting up there. I want to make sure I can get the exploration going to the point that we can use our tools and bring back the information during my lifetime. That's half facetious. The 4 terrestrial planets, Mercury, Venus, Earth, and Mars. In fact, all of the planets, except for that poor captured orphan Pluto, we'll talk about that later if somebody asks. These were all created at the same time as our sun was created. It's a family, but we've all evolved differently. And that has to do with the function of time, space, proximity to one another, proximity to the sun, and proximity to the gas giant planets, because they exert their own not insignificant gravitational tug. Earth and Mars are very close together. And the thing about them is, while being formed at the same time, the difference between their positions relative to the sun and to Jupiter has created a very different set of environmental circumstances. Earth is a place replete with life, replete with water. Mars, it has some water bound up in minerals. It has some water ice, very little water vapor in its atmosphere, is arid beyond arid. It is a desert, unlike the deserts we have on Earth. Our driest deserts, the Atacama probably being the driest, are not anything close to what we see on Mars. Something happened a very long time ago on Mars. It happened to the Earth and all the terrestrial planets. It was a bad day to be any of them, because what happened was giant rogue asteroids went flying through the solar system, impacting the heck out of these planets. In some cases, the planets were too small to withstand the barrage. They completely remelted, and they appear to be devoid of life. It's not impossible, but we don't see it at the surface. I would like to know why. I'd like to know, as a function of time, is that something because of the timing of these impacts? Is that something that awaits us in our future? Was there ever a biosphere on Mars? If there was, can we find evidence of it? In order to be able to explore Mars and not be completely dependent upon only the information we have Earth, we would have to be able to imagine life as we don't know it, because the only life we've ever been acquainted with is the life that we see on Earth. So in seeking to understand what makes environments become habitable on Earth or uninhabitable, in order that I might be able to better predict what a habitable environment might look like on Mars, I've spent a lot of time on the Earth exploring very dry places. I've explored the hot deserts and I've explored the cold deserts. This image on the left of your screen, these rock protrusions are lava tubes. This is what is now an extinct volcano called Svarafjell, and it's on one of the islands in Svalbard, which is an Arctic archipelago, which is governed together jointly by Norway and Russia. I've spent a lot of time on this volcano, and the reason why we have been there is because there are minerals there that have altered from the basalts that make up lava, volcanic rock, that look very similar in their texture and composition to minerals that we see in Martian meteorites. And so it's an ideal analog, although it's not Mars, it's an analog for what we might find on Mars. This image slightly to the north or closer to the top of your screen, that's Badwater Basin in Death Valley. It's the lowest terrestrial spot on Earth. It's extremely hot in the summer. The only way you can work at all, even in the late spring, is to do so before dawn and before the sun is sufficiently high over these mountains in the background that the sunlight itself doesn't fall on you. It's just remarkably hot. This white stuff is not snow. These are what we call evaporite minerals. What happens in the winter and early spring is we get periodic deluge of rain in Death Valley. And as the water evaporates, sulfates and carbonates, these mineral salts, precipitate, and living things take up residence in the pore spaces of these minerals. I'll show you some of that in a bit. This image down here is a place called Battleship Promontory in the McMurdo Dry Valleys of Antarctica. It's on the polar plateau of Antarctica. I led an expedition there in 2005. It was the coldest 5 weeks of my life. I used to clutch a plastic bottle of water that I had boiled. I would throw it into my sleeping bag and hold on to it at night. And I would read stories of mountaineering disasters to convince myself that I didn't really have it so bad. It was so cold. It's easy to go to a place like this on Earth if you know where it is and you have the resources to get there. Because I'm a scientist, it was my job to go to these places. I wrote proposals for NASA to fund me, and I was fortunate, and I was funded to go there. I miss them now that I live on the East Coast. But this is the same Badwater Basin that I showed you earlier, and now you can get a closer up view of some of the textures of these minerals and the different colors. You'll see the tans and the whites. Now, what I'd like you to know is that I can go here whenever I have the time and the resources to go there. But if I want to go here, I require a lot more resources. I can't physically go there myself. These mountainous humps here, that's the foothills of what we call Mount Sharp, which is a giant mountain in the middle of Gale Crater, Mars, where the Curiosity rover landed on April 5th of 2012. I worked on that Mars mission from about 2004, when we wrote the proposals for the instruments, all the way through to 2017, when in order to finish seminary, I just couldn't do everything all at once, developing the mission I presently work on, doing tactical operations for this mission, and finishing seminary. So I resigned from that mission. But I show you this picture because it looks like any desert you might see on the Earth. But in order to explore it, we need a little help from a friend. And this is our friend, Curiosity rover. My instrument team was called Sample Analysis at Mars. It was a suite of mass spectrometers, which are instruments that ingest either gas or heat up solid material, such as the regolith and rock, and let off gas from it. And then as the gas goes into this analytical tool, by the mass of the fragments, we can tell what the chemical elements are, and we can see what it's made out of. So SAM is the acronym for the instrument, and SAM had two little trap doors in the top of the rover deck by which the rover arm dispensed material that was powdered and drilled from rock. And then you can't see it, but on this back side of the rover, we had a little atmospheric tube in which we could suck in air and measure not only the chemical elements in the atmosphere, but also the ratio of heavy versions of a chemical element to light versions of that element. We call those isotopes. And if I tell you things you already know, you can say, yeah, we know that. You can signal that I'm making it a little too detailed for you. But basically, it's really important to make this measurement of all of the chemical elements, which in a stable way are able to show a heavy and a light version, because that ratio tells you something about whether or not they were made by life or some other processes that might be valuable to understanding that environment. So it was thrilling to explore that desert environment on Mars. But as I said, I stopped working on that mission a while ago. And now I'm exploring this environment. It's a place called Jezero Crater, also on Mars. Just to show you where it is on Mars, the relationship between all the various Mars missions and the mission that I work on called Mars 2020, here's where we are. Here is where the Viking landers from 1975 were. And here is the Pathfinder, which was the first actual rover that landed on Mars. Then a pair of missions, Spirit and Opportunity. They landed on Mars, and I think it was 2004, can't remember. And then Curiosity rover, which I told you about in Gale Crater. And here's where we are. And this would be the polar region up here. Now, how do you figure out where to go if you're going to Mars? These are expensive missions, more than $2 billion for Curiosity. That was $2.6 billion, because the Perseverance rover is a build to print version of that. It was slightly less expensive, but still it costs a gazillion dollars to mount an expedition like this. And it is not without some ethical conundrum on my part that I participate in these things. We can talk more about that in a little bit. How do we figure out where to go? We use orbital images and orbital spectroscopy. The images to show interesting textural features that are consistent with what we know are processes that form those features, and the spectroscopy to tell us something about the nature of those materials. When we figure out the general area where we're going to go and where we agreed to go in a community-wide series of meetings is this place called Jezero Crater. We went there because it has evidence, in other words, morphological evidence of what used to be a delta, which is a formation that we get on Earth when rapidly moving water, such as from river, enters a bigger, less active body of water. So for example, the Mississippi River drains into the Gulf of Mexico and has a big delta there. We thought a delta might be a good place to sample all the things that the river has entrained in it as it emptied into a sea, which at once upon a time was in Jezero Crater. The way we figure out how we're going to understand the rocks there was a huge effort by a big team. We divided the whole area into these little squares. We call them quads, just like the topographic quadrangle maps we use on Earth when we go hiking. We named them all after national parks from various countries all over the world. I mapped this one called Ha Long Bay. And it is just outside this blue circle, which was our landing ellipse. And we landed pretty much dead center in the middle of our landing ellipse. But when we did this mapping exercise by using textures and by using structures and by using the limited amount of spectroscopic information we had from spacecraft orbiting Mars, we were able to make theories about what kind of rock was there and what might be promising rock to host and preserve organic chemicals, which could potentially be evidence for life. I want to show you the delta. This is what a delta looks like. And one of the interesting things that you can see in the colors here, these colors are false colors that give you a little bit of chemical or mineralogical information. So the thing about this delta is we wanted to get close enough to it that we could explore it, but not so close to it that we would crash into it when we got there. So where we landed was right here. You can see, by the way, these craters. Mars doesn't have what we call plate tectonics. In other words, on Earth, we have these big segments of land that move around on the surface, and they will dive under one another. They will butt into each other and cause mountains to form. They will even slide along each other and create earthquake faults. Mars doesn't have that anymore. Remember, I was telling you about the time when early in the formation of the solar system, these big asteroids were blasting through the solar system. It was about 4.1 to 3.9 billion years ago. What happened to Mars was that it lost its magnetic field. You have a magnetic field in a planet because you have molten metal at the core. But if what happens is that you're too small and you cool too fast, all this iron juice stops flowing. You don't have a magnetic field anymore. Then it's a really bad day to be you, because that magnetic field protects you from harmful ionizing radiation coming at your planet from the sun and from the background galactic cosmic rays. And that harmful ionizing radiation rips the atmosphere away from the planet. The atmosphere gets thin. You don't have anything moving around on the surface. So things that happened a really long time ago just stay there on the surface of Mars. What does that mean for us? It means if we want to explore our deepest past, we can't, because the surface of the Earth is so dynamic. The surface has, as I said earlier, some of it has dived down beneath other places in the surface. It's been covered by new sedimentary rock. The farthest back in our history we can go is about 3.8 billion years. And most of that is just detrital stuff. So if we want to see our deep past, we can see it on Mars, but not here. But in order to know whether that's relevant to our deep past, we have to understand the differences between Earth and Mars. So Mars is interesting as a potential site for evolution of another biosphere. It's interesting because it allows us to understand something about our deep past. And Mars is intrinsically interesting because we want to understand, do the minerals that we see making rock on Earth show up elsewhere? The meteorites tell us they do. But every chance we get to study them on another planet informs us about our own. So let me tell you something about the process of getting there. It can take as little as 7.5 months, or it can take as long as 2 years to get to Mars. It depends upon when you launch to go there, because the relative position of the planets rotating around the sun, Mars being further away from the sun than Earth, has a much longer year. In other words, a much longer circuit around the sun. So it's possible that at different times, Mars is a completely opposite place around the sun. It's also possible that the gap between Earth and Mars is twice as long a journey. So you have to predict carefully the celestial bodies' places, and then figure out when is the right launch opportunity. And then you have to work like hell to get there in time, because if you miss that launch opportunity, you've got to wait for another favorable one, or else you need to have a whole bunch more fuel to get there. It's really complicated. But we built our instruments, we made our launch window, we took off, and then we arrived about, well, really almost a year ago now. It'll be a year in 3 weeks. We landed on February 18th last year. So when we got there, it was amazing. We had, I'm going to share my screen again. I'm going to show you something so cool. On the spacecraft that lowered the rover down to the surface, we had a camera that looked up. And as the parachute opened, we watched it open, not in real time. We had to get the images back, but we could assemble them in what looked like a video. This is looking up at the parachute while we're coming down to the Martian surface. But wait, there's more. We also had a downward looking camera. And there we are on the cables, the nylon cables that were lowering us to the surface of Mars. At one point, we had these pyro devices that fired, flinging off the cables. And then we had rockets that, through thrusting against the Martian surface, would slow our descent to enough of a level of gentleness that we wouldn't bust the rover by landing. So that was really cool. We've never seen our own entry, descent, and landing in such detail before. You see all these swirly patterns in this. I'm not sure how much detail comes through in Zoom, but it looks almost like the way iron filings look in a magnet. It's really cool because this is the sediment and dust being blown by our rockets firing. So that's the evidence that they fired okay just before we let go of these. So we landed, and much to our great delight, the first pictures that came back, we were right side up and we were on the surface of Mars. It wasn't long before we took one of these famous selfies. And there's Perseverance. Look how clean she is. Now she's all covered with dirt and sand and all kinds of stuff. I am a co-investigator to one of the cameras that's on the wrist of the humongous rover arm. We turn it around and then we aim it back at the rover. It's called Watson. I'll show it to you in just a second. So here we are with our little tiny friend, Ingenuity, the helicopter. I am not an expert at Ingenuity. More people ask me about that than anything else on this mission. All I can say is, to me, it's like a miracle how it operates, but it operates well. We were supposed to fly again yesterday or the day before. We couldn't. There's been a lot of dust lifting and heavy dust storms on Mars, so we want to take good care of Ingenuity. So we're waiting before the next flight. Anyway, I showed you those cool pictures, and I wanted to make the point that we have so many cameras. We have 23 cameras on this spacecraft. Some of them are engineering cameras and some of them are science cameras. And then all of those cameras that enabled us to visualize our own entry, descent, and landing. There were 7 of those. We also have 2 microphones. For the first time, we've been able to record the sound of the winds on Mars. That actually has a scientific purpose. We have 3 wind sensors in our meteorology package. And we can use the data from our wind sensors with the pitch of the microphone data of the wind moving to try to determine wind speed and direction, which is really important for understanding things like, is it safe to fly the helicopter? Is it safe to core a rock, process it, and put the lid on the little tube containing the rock sample without a whole bunch of dust blowing in there? So we use that meteorology data a lot. The cameras are in the back of the rover. They are in the front of the rover on the mast. They're in the front of the rover looking down for hazards. And then the cameras that I work with, the Watson camera and the context imager, are on the wrist. So the reason I'm making a big deal about all of these cameras is to give you a sense that When you go sightseeing and you're taking pictures of everything, you're doing exactly what we do when we're doing scientific exploration. We want to look at those images when we return from our trip. I promise you, you'll see things in those images anew that you didn't notice when you were there. Your trips, your explorations can continue to inform you long after you've unpacked and done your laundry at home. One of the instruments I'm involved with in the Perseverance rover mission is one where we take close-up images, kind of like a microscope. These are all images of spots that we have abraded on rocks on Mars. And these are cores, and these abraded spots represent cores that we have extracted and we have cached in little sealed tubes so that a subsequent mission can return them to Earth. Why is it so important to return samples to Earth? Well, two reasons. One, the samples have their own intrinsic value. And two, if we can't bring back a rock, how are we going to bring back a human? So it's really important to develop that technique of ascending from the Martian surface to a return spacecraft, safely re-entering our atmosphere and having everything remain intact. We cannot begin to attempt human exploration of Mars until we've accomplished that. Hence, one of the goals of this mission is to prepare for human exploration. My overarching question when I explore the Earth and when I explore Mars is this one. Can anything live here? Now, after many days of being, how shall we say, safely sheltered in my home during this pandemic, I ask myself, can anything live here? Is my life going to be affected by being only in my home? I'm one of the luckiest people because I have had the opportunity to live in the middle of the woods. I can look out the window into this gorgeous ravine, see the trees, I can see the wildlife. I walk my dog, I stare up at the trees. I have this computer on my desk with two humongous monitors. I can see you. Can I still explore? Yes. It's important to note that exploration never stops, whether you're at home or whether you're on Mars or whether you're in the deep field on Earth. When I ask myself if anything can live here on Earth, it's a little bit easier because there are some telltale signs that tell us things can live here. There are some obvious signs here that tell us that there's something alive. But they're only obvious to us because we live on the Earth and we're intimately familiar with the evidence. And that evidence is that there are green things. I'm not sure how well the color saturation comes through on Zoom, but this is all green here. This is the floodplain of this river, which is in the Northwest Territory of Canada. At some point, you cross over into the Yukon. I went up to study Llewellyn Glacier, ice algae living there. And you see all that black stuff in the ice there? It's not dirt, it's algae. It's actually a dark red. And it is amazing how robust the community of algae is on Llewellyn Glacier. It's in Canada. So there are signs of life here. There are signs of life here. Sometimes they become less cryptic. There is no life here. These are not shrubs. These are rocks. That's one of the rock outcrops in Jezero crater. Sometimes it's not so clear. This place looks devoid of life. This place looks replete with life. But when you go here, it's a little bit ambiguous. One of these is Mars, and one of these is Earth. And yet look how similar they are. They both exhibit the types of sedimentary rock structures that we see on Earth, telling us something about the processes that laid down the sedimentary rock. They both show no signs of anything recognizably alive. What you see here is a mirage. That's not a lake, it's a mirage. This is actual water. This is Palander Canyon in Nordaustlandet, which is the northernmost island in that archipelago of Svalbard. This rock, we don't know if it has life in it. The Mars exploration rovers and their technology at the time had no way of interrogating these layers of rock. However, I was able to walk right over to these layers of rock, provided somebody was standing guard with a rifle in case a polar bear came. By the way, an interesting little tidbit, the man standing guard with the rifle while I walked over here is the principal investigator of this Mars mission, Steve Squires, a professor at Cornell. Anyway, Steve was guarding me as I walked over to this rock outcrop. And upon examination of these layers of rock with a hand lens, it was easy to see that there were microorganisms living inside the rock. We find those commonly on Earth. They're called cryptoendoliths. And that simply means organisms that live in pore space. There are places that you go to that just seem otherworldly, but yet this is our world. During the Cretaceous era, that's the time where dinosaurs roamed the Earth freely. This area here had a shallow sea. This is in Canada at Dinosaur Provincial Park, which is a clue to what I'm going to tell you next. There is nowhere you can walk in that park where you don't see a dinosaur bone. It just looks dead. Now, if you look carefully at the photo image, this is some grasses right here. But if I just zoomed in on this part here, you wouldn't have seen that, or this part here beneath the grasses. Dinosaur Provincial Park is one that had life and it had active flowing water. These kinds of structures show you water that had down cut and then pooled, leaving these little plateau-like things. And the action of the water gave you these rock formations in this fluting kind of texture here. And the dinosaurs died. And we now have their graveyard available to us. Everywhere you look, there are fossils. This is a discovery that I made when I was there. This is the pelvic assembly of this dinosaur. It's called Prosaurolophus. This is my little field knife for scale. It's about 3.5 inches long. See how easy it is to discover a new dinosaur? Okay, I already showed you the algae. Now let me get back to something much more important than algae, and that would be fun. Exploration has a biological purpose, but that doesn't mean it's not fun. Exploration is awesome. During my 9 trips to the Arctic, there was always a group of people who usually were newbies who were selected to go out in what we called a Zodiac, a kind of an inflatable boat with an axe, hack off a piece of an iceberg, haul it into the boat, and bring it back so that we could hack it into smaller bits and serve gin and tonics over it. And so we got to about my 8th season and we realized I had never gotten to go because I was always picking who was going. So I finally got to go and hack up my own piece of iceberg. And this is me being king of the world for a moment. At the other end of the Earth, in Antarctica, I already told you about the 5 cold weeks. This is our campsite in this valley here. we were here to study these rocks, which were the place where it was first discovered that organisms live in the rock, and they live on the rock's materials. They breathe iron. The iron is blown in from this basalt down here in the valley with the katabatic winds of Antarctica. It's deposited on this white, like Wonder Bread white limestone, sandstone. And as the organisms receive some moisture, not much, but some, and the iron from the basalt, they essentially metabolize that iron. They breathe that iron, changing the iron from one form to another, making it red, creating rust. And I wanted to study that strategy of organism and see whether the instruments that we were developing could detect it, could detect the life there. The instrument that I work on, one of the instruments I work on the Perseverance mission, is the spiritual daughter of the prototype instrument that we tested here in 2005. We hiked up this incredibly steep hill and looked down at our campsite. You might wonder why this tent is very far away from all these other tents. Anybody got a good guess? It's the toilet. Nobody wants to go next to the tent that has our instruments or the tents where we sleep. So we put it back over here. Just thought you'd find that interesting. This one down here is the kitchen tent. And then my little tent was this tiny little hump right here. Let's say right there under my cursor. All right, now I'm going to stop the screen share, and I want to digress to the more philosophical aspects of exploration for a moment. I think exploration is key to our survival as a society, because right now we're being siloed into camps. We receive our information in an ever narrow set of sources, and we divide ourselves as a society because we're unwilling to explore the ideas of the people with whom we disagree to a large extent. If we know that that's happening, we can open ourselves to trying to recognize what people are thinking and what people are doing, and that requires active exploration. I think it's valuable. So I've come up with a little set of considerations that I'd like to try out on you. I usually offer these as my commentary when I'm talking to students. And I want to offer them to you because you have made the commitment to be lifelong students. That's a commitment I have made as well. The first consideration is you can't always choose your environment to explore. So you just start where you are. You can always choose who you want to be in that environment. That's important because all organisms are colonial. All humans have historically been colonial. I am not talking about just colonialism per se or imperialism, but what I'm saying is organisms seek to exploit their habitat, and then they look for new habitat, and they often compete with the existing species. We can, by intention, choose how we treat pre-existing inhabitants of a niche, and that's something we need to think about. There's nothing more disconcerting than watching a swarm of geologists attacking an outcrop, everyone with hammers out, hacking it to bits. It makes you realize that once you've destroyed it, there's nothing left of its context. So we have to think carefully about who we will be as we explore. You can choose how you will take care of your own exploration tools. You can choose what goes into your mouth, and you can choose what comes out of your mouth, what you eat and what you say. There are implicit biases in our approach to exploration and even to science for that matter. And so who we are, how fit we are, how healthy, and how civil we are matters. What goes around comes around. We are all subject to peer review when we invoke science. So it behooves us to learn to be civil. To explore a new territory, you have to be bold. I showed you the upward look at our parachute when we were landing on Mars. We have a saying at the Jet Propulsion Lab, dare mighty things. The layout of the parachute design actually spells out dare mighty things in Morse code. I ordered the dress. Don't be afraid to try new things. It does require some boldness. Don't prejudge what you're going to find, and don't be afraid to try new methods of exploration when you're there. They might make you uncomfortable, but that's not necessarily a bad thing. Don't let anyone talk you out of trying to learn something new, to prepare to explore. You're doing that right now. Don't be shy about asking questions. Don't be afraid, period. It never helps you. It's good to be cautious. You don't want to die while you're exploring, but don't fear, just be cautious and respectful. 9, you only have one body in this life, so take care of it like you're training for the Olympics. You need those senses. We can't help some things. I'm starting to get little tiny cataracts in the visual center of each eye. When they get bad enough, I'm going to take them out. But I can do all kinds of things to enhance my visual acuity right now. I can use a big old camera with a high resolution lens. I can bring friends who are also observant. There are all sorts of ways to make up for what we consider to be declining expertise or capability. My last piece of advice with respect to exploration is, again, exploration is best achieved as a team activity. Therefore, we do have to be kind to everyone without exception. It could be the difference between life and death in a situation where you're on an expedition. The kind of expedition where we go to learn and to explore is every bit as rigorous and thrilling as the expedition where we go on an adventure. It's just conceived of for a different reason in the beginning. No matter where you are, whether you're exploring a geographic locale or an idea landscape or a spiritual landscape, there are always new questions to ask and new input to process from which you can make inferences. Mostly, it's just really, really fun. I think if I were to leave you with a take-home message, aside from the fact that you're going to explore anyway because it's a biological imperative, you just never know where you're going to end up and who you might end up with as friends, as these little Adelie penguins, which I wasn't permitted to touch, but of course I couldn't keep them from touching me. I'm going to remind you one more time of my email in case you don't lose your shyness before the end of our time. I've tried to leave you with a good half hour so that we can get the conversation going. I'll bet you have things to teach me and I'm anxious to learn what they are. So unmute yourselves and speak up. Yeah, go ahead, Bob, but you'll have to unmute.
So, based on your life experiences, what's the most profound unanswered question that you have?
So I have so many questions. It's really like telling a kid to go into FAO Schwartz and pick out one toy. But I think the top of the list is, are we alone?
Mm-hmm. So what have you learned in Mars relative to that? And being alone, does that mean something is humanoid or something that's something microscopic?
What I'd like to know is whether or not there is life that has created anew in some other place in the solar system than Earth. Because the second biggest question is, are we the seed? Is the solar system waiting for us to go there? I don't know. I
Has your-
haven't seen life yet, if you want to know.
Has your
Yeah,
work
go
on
ahead.
has your work on Mars shown whether Mars is capable of sustaining human life?
We have not seen anything on Mars that would tell us Mars could sustain human life without substantial technology to protect us from ionizing radiation, desiccation, the wrong mix of gases in the atmosphere, and very low partial pressure of the atmosphere. There are also extremes of temperature. And one of the industrial threats we have on Earth is very, very tiny dust-sized grains of silicate minerals, which are very, very hard, are a lung irritant, in fact, a carcinogen. So Mars has a lot of that too.
Pam, I have a question, and that is, have you detected any bacteria or bacteria remnants on Mars?
No,
What was it your paper talked about, that just the one that just came out in Science Magazine that was inconclusive?
so the paper that we just published last week was about a careful analysis of a very famous meteorite, which in 1996, a team of investigators hypothesized that we had evidence of life in a meteorite. After years of debate and analysis, we have mostly achieved consensus that yes, there's life in the meteorite, but it's terrestrial contamination. And the organic materials that we see associated with the minerals in the meteorite in our analysis are created by a process of rock alteration that we commonly see on the Earth called carbonation. And the take-home message that's important for that is less about life and more about how a planet's chemistry can become more and more complex and do the kinds of things that allow a diversity of materials to remain stable so that they could be used by a living thing. It doesn't preclude life, but it just reinterprets what we think about that particular meteorite.
Pam, this is Steve Goldman. Can you hear me?
Yes, I can. Go ahead, Steve.
Is it possible that rather than being the seed, that we are the progenitors, I guess, of life that came here from someplace else?
Yeah, and certainly it could be possible. That's a theory that's known as panspermia, meaning that life started elsewhere and ended up here. We just don't know the answer. And the only way we will know the answer is if we find it somewhere else and then take a comparative look to determine, is it genetically similar or chemically similar enough that we deem it must be related? It's a tough question.
And this is John Miller. Can you hear me?
Yes.
What do you suspect we might learn from the Webb telescope? And how might that affect the work that you were currently doing, NASA's currently doing on Mars? Would it shed any light, presumably, I guess, on much deeper time than we can see on Mars? But it seems to me as this is a huge step in exploration to have a space telescope of this kind of quality.
So the James Webb Space Telescope will be able to see much dimmer features, and those features that are more distant, therefore further back in time than the Hubble telescope has been able to see. And because the Hubble telescope is aging, it was time to replace it. It's been time for a long time, but unfortunately, the James Webb Space Telescope was delayed many times for various and sundry things that occurred. I would not say that the telescope is directly related to planetary science. Cosmology and large astronomical questions are, of course, related in a sense to specific planets. People who explore Mars are more like geologists on Earth and paleontologists and astrobiologists. That being said, when we use an asset like the James Webb Space Telescope to see more distant star systems, we, of course, will come up with a new catalog of what we call exoplanets, planets that are outside of our own solar system. And as we use the spectroscopy that is available to us, we might be able to see chemical features that would suggest that there are processes happening on those exoplanets that are not something that is just a geological atmosphere equilibrium, but something that could represent the activity of life. It's a big stretch. And with maybe one pixel of information and something very distant, it would be very tough. But when you think about the relationship between specific planets and the larger systematics of how planets form and how common certain sizes and proximities to their stars may be, in a sense, it's related, although I would say less directly so.
Pam, you said that one of the reasons you landed in the location that you did was that you would see the streams of the way that the water had eroded part of the Martian. Do you have any feel for how long ago that occurred?
So you can, by looking at features that occur and counting how many craters that you see on the surface, that is the way we date large scale morphologies on another planet, by counting craters. We also have a sense of certain materials and the age they were created on Mars because of Martian meteorites. But the whole point of this mission is not only to characterize the geology and the climate and to look for signs of life and to prepare for human exploration, but perhaps our most compelling goal is to core samples and return them to Earth. So in that regard, you can't definitively date anything on the surface of Mars. We have a relative sense. These are the rocks that we are exploring right now. We can say which layers are older than other layers just because of their position relative to one another. There are estimates of their age. They have not been published yet, so I can't offer that just yet because of our rules of the road. But those are just very general ways of constraining the date. When we get them back, we can use these radioisotope methods to date them precisely.
I was interested more in the interaction with water. How long ago was the water on Mars that created these rivulets and those features that you're seeing on?
So the only way you can know that for certain is to take the rocks that were precipitated within those waters and date those. So it's all tied up together. I can tell you it's old, a long time ago.
Mhm.
I just can't tell you the precise age. I can tell you which era of Martian history.
Does that
we
suggest, if water did exist, does that suggest that life might have occurred on Mars at that point?
So first, the caveat, I am a contrarian. There are a lot of people who want to say we have found evidence of life on Mars and Mars is habitable. I say it's more than just a collection of chemicals. You also have to understand the physics of the environment. So we haven't seen any chemical showstoppers that would preclude the formation of life. It is possible that in the window of time since Mars was created and before that late heavy bombardment, when we think is when it lost its magnetic field, if life evolved very quickly in that first 500 million years, it might have taken refuge inside the rocks in the subsurface. We have subsurface life on Earth. And if it's there, if there's by some process that the rock was lifted up, we would be able to look for fossil evidence. So yeah, there could have been life. There might have been. My suspicion is that there wasn't, but that's just my opinion, not because we have evidence that's contrary.
I think we have, our youngest member of the group has a question, it looks like.
Yeah, go for it.
What's your favorite type of rock, and is it igneous, sedimentary, or metamorphic?
Oh, that's a great question. So for those of you that don't know your rocks, igneous rocks are the things that have crystals all close together and they come up out of the earth, essentially. Sedimentary rocks are like when you make a layer cake, you crunch up things from existing rock and you deposit it down in water, and then you stick down another layer and then another layer and stuff like that. If rock were cake, I'd like sedimentary rock because I love cake, but actually I love igneous rock. And what you will see in igneous rocks is what's happening on the inside of the planet. And that's why I think they are so cool. And plus they're so cool when they spew out of a volcano.
Pam,
Yeah.
can you hear me?
I can. Go ahead, Stan.
Yeah, Stan. Okay. So all the landing rover, all those missions to Mars look like they're in one area of Mars. Is there a reason that they're in that one particular area of the planet versus the other side of the planet, etc.?
So it's a little bit misleading the way we do this projection. And that's just because in order to show both sides of the planet, you got to like stretch it out. But this side actually connects to this side. So you're seeing the whole planet. But what you will see is that with respect to top and bottom, the poles, we try to stay more equatorial. This Phoenix mission was closer to the pole. And the reason they went there is because we knew there's water ice near the pole. And the reason why Viking 1 and Viking 2 were at two different latitudes was to see what the differences were. And they were landers. But you're right that all of the rolling assets are more at mid latitudes. And there's a reason for that. And that's because the little motors, the actuators, are subject to wear and tear. And the thermal extremes at the poles would stress our hardware too much. So we play it safe with a gazillion-dollar rover and we try to stay in a more moderate temperature. But they're on, they're not all on one side of the planet because the planet's always twirling around, right?
And I had a question about, I know you said that the helicopter was something that's not within your field of extraordinary expertise, but I don't quite understand. It's going to collect material and it will use its propeller in the Martian atmosphere, which is very thin, to get up high enough to be picked up by another mission that will then bring it back to Earth. Do I have that correct?
No.
No. Okay, good. How I embarrassed to ask the question. No.
So no, don't be embarrassed. So we have, actually the drilling system is extremely complicated. And we have different bits that we use for different things. And we would never be able to fly that stuff on this helicopter. what you'll note from the image I showed you is the blades are huge relative to the size of the little body. And the helicopter was just a tech demo with a camera to see whether or not we could get something to fly on Mars. And it's achieved by these two humongous blades, which create enough pressure in between them to actually achieve loft. It's battery powered, and it's battery powered rechargeable by a solar cell, and it communicates with the rover. So the tech demo part is done. It worked. It just keeps on working. So we're using it as a scout. Go over there and look over that hill and see what you can see. Should we go there? And so that's what we're doing now.
I have a
Um,
question.
Well, before you ask your question, let me just answer the question in chat, which is what's a moderate temperature on Mars?
Sure.
Unfortunately, moderate on Earth and moderate on Mars are really different. So the temperature in the midst of a day, kind of near where we are, can swing by about 100 degrees. So you can be very, very, very cold below 0 Celsius, and you can get very, very hot very quickly. And so if you were to have ice form at night and then the sun came up, poof, it would sublimate immediately. So it's hot and it's cold. There is no moderate, actually. Okay, go ahead, Suzanne.
Have you always been interested both in religion and science? And when you were deciding about your career, did you get pulled in two directions? And when you decided to go back and learn a little bit more about the religious side, did you have any sort of influence from your scientific interests that swayed you one way or another?
Actually, you only know about 2 of my 20 different careers. So yes, I have always been interested in science. And yes, I have always had an abiding interest in spirituality and faith. My parents were very anti-faith and religion. I learned not to speak about God around the house, although I was able to learn things that I needed to learn out of the ether somehow. And so they were never in opposition. I was interested in both. I was also interested in music and art and everything. So everything I have done influences everything else I do, because everything is a system and we live within the system. And so I see science as one way of knowing things and faith as another way of knowing things. And the questions that intrigue me are such big ones that I want to use every approach I can to ask questions and to try to address them. So I would say that certainly my exploration of nature has influenced my faith, and my faith life has clearly influenced my practice of science, particularly when it comes to things like colonialism and understanding that a given field site is not mine to plunder, but the appreciation for the connectedness of everything is completely consistent across the board. I will also say that my career as a professional musician was what facilitated my ability to learn to appreciate vibrational spectra. Everything in the universe vibrates, and it all has a detectable frequency of vibration. And so it's so akin to the audio vibration that is music. It made it much easier for me to learn.
Cool. Thank you.
Sure.
And do you still continue your interest in music? I know you're busy with the church and also with your scientific research on Mars, but do you have an opportunity to sing, to listen to music, to go to concerts, or is that something you hope to do at some future time?
Right now, I am praying for enough decline in COVID cases that I can go to see the premiere of Toshi Reagan's opera based on the Parable of the Sower by Octavia Butler, after whom we named our landing site, famous science fiction author who wrote a pretty shocking dystopian pair of novels that are not out of the realm of possibility. That's in April at the Strathmore Arts Center in Bethesda. I don't go to concerts right now because of COVID. Do I
Sure.
go to them when it wasn't COVID? Absolutely. Do I do music? Yes, I have a recording studio in the basement. I also have a piano in the living room. I play several instruments. I write music. That's sort of an essential part of who I am. So it's not a thing you make time for. It's just a person that you are.
Well, you are obviously blessed with many, many different varying and maybe conflicting talents. I just wonder, do you feel any tension at that intersection of spirituality and religion?
None.
How
What I
do you
feel,
manage
how do I manage it?
Mhm.
So I see everything from a systems perspective. Certainly, institutions tend to grumble at one another. I would say that my experience of the scientific community taught me that I was really wrong to judge how they would react when I came out of the closet, so to speak, about seminary. And I said, well, I'm going to drop off this mission. I'm going to go be a priest. And I was afraid they'd step back a couple paces and look at me like I was from Mars. But instead, even though they said, oh, I didn't know you were into religion, they would proceed to use me like a pastor and tell me all their various experiences. And I realized that the persona that people often feel compelled to portray as a scientist as at odds with what is in their deepest self, and that there was no conflict within the science community. They all know about it. I have people send me emails to ask me questions about religion from the Mars rover team. And I thought, oh, I better not tell people about this. In the other respect, from within my church, my parish, they all know that I do the science thing. I was initially a little afraid that they would think I wouldn't be giving them my full attention. But I've been very clear that the science part is very part-time at this point. I have to make my people my first priority. We're in the middle of this pandemic. So from the perspective of the Episcopal Church, which has as one of its foundational principles the use of reason, I have never had anything but very vibrant support amongst people who tend to be from different faith practices that are a little bit more what we would call congregationalist. My sister, for example, is a very, we use the term evangelical incorrectly. It doesn't mean people who have a specific set, but people who are biblical literalists, and people from my sister's faith community are very anti-science. They feel like science is in conflict with faith, particularly with regard to the concept of evolution and how long it took to form the earth. I have argued to them that I think evolution is proof of God, because if God made everything, that means the whole universe resides in God, and therefore the nature of the vibrational energy which enervates everything to move and therefore evolve because it changes positions with respect to other things is caused by God. So that's how I address that particular problem. And generally it ends up with, I'm going to think about that some. So my personal experience may be different than the experience of others, but I haven't found, except for one guy on a blog who attacked me when I said, we shouldn't be so arrogant as to assume that we humans are the pinnacle of creation.
Pam, I have a question for you.
You're welcome.
What role do you have as a North American warden of the Society of Ordained Scientists?
Yeah.
I had never heard about that before until I found that was one of the many things that you are involved with. Could you explain what that does? That organization?
Sure. The Society of Ordained Scientists is a contemplative order to support people who live sort of in both worlds. It was founded by Sir Arthur Peacock and Sir John Polkinghorne, both of whom have passed recently. And the idea is to pray for the list of members, 10 at a time every day, and to attend the gathering in the United Kingdom once a year, and to be a sort of amalgam of what has often been perceived as two separate worlds. My role as the warden means sort of like president, to define our operating program for the year, to produce a retreat for our members every 2 years in North America, and to provide pastoral leadership to the members, and to talk to people who might be interested. We have a rule of life, and the rule of life is basically to pray for one another and to attend the gathering, or to attempt to attend the gathering when possible, which has been difficult with COVID.
Mhm.
Thank you.
So Pam, you have a question in the chat. I
Well, let's see. So just in case somebody cannot see the chat, the question has to do with, how has my Mars exploration substantiated Genesis 1 and 2? In the beginning, God created the heavens and the earth. Now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God hovered over the waters. So waters is a term that's used in the Old Testament not to mean water per se, but but not solid. And so what I have learned from exploring Mars is that God is bigger than the notion that we have of God, and that if God can create one world, God can create 9 or 10 or 12 million. And so I think it's a perfect justification for exploring beyond this world in order to understand just how huge God is, and just how amazing the diversity of things in the universe may be. Out of the same set of chemical elements, which are observed everywhere throughout the universe, we have all of this, all of the stars, all of the earth, all of the people, elephants, microbes, chocolate. It's amazing. So what I see on Mars is not unlike Earth. I look out over the landscape, and it could be the desert where Jesus underwent the temptation.
So Pam, as we come to a conclusion today, because we're almost at 5:30, you started off by talking about how, well, I guess you could say this, how divided we have become by not, and it sounds, by not keeping our minds open to what other people think and what other cultures think. What would be your final thoughts in that relation as we consider everything that you've been talking about today? How do we solve that problem?
I think that exploration is fundamental to solving that problem. I think the reconciliation of people to one another is only possible in conversation and in the exploration of each other's ideas, closely held views, because when we learn new things, we adjust our views. I've been reading a book by the late chief rabbi of Great Britain, Jonathan Sacks. It's called Morality: Restoring the Common Good in Divided Times. And he speaks eloquently about this problem. And in fact, he talks about Nietzsche, who, as all of you know, was a famous atheist. He says it was Nietzsche who first saw what was likely to happen when truth dies and trust dies. When people give up faith in religion, it would not be religion alone that we lose. We lose morality, and with it, a concern for truth. And then even science loses its authority. Science, he said, can only function if we bring to it a prior conviction of morality. And so I think in exploring, we become more open to different interpretations of the truth, and we become more skilled at that conversation and at crossing boundaries in order to explore the opportunities and the threats. And so I commend to you all, first of all, Jonathan Sachs and his book on morality. And I commend to all of you and beg you to continue exploring until you breathe no more. There's plenty left to learn.
Well, thank you so much, Anne, for sharing this time with us. We've all learned a lot from you, and I hope we see you in the future. That's
Yes.
I could see you coming back to us and making sure, keeping our hand in the fire in terms of keeping us honest in our endeavors to keep learning.
Pam, and
My
I also-
pleasure.
I thank you again for your coming to us via Zoom. And I hope you will stay in touch with us and perhaps even send us some of the books that you are reading. They're of great interest. And
Absolutely.
when
And I
look out
apologize to you. I didn't get to talk about my underwater exploration. And so if you invite me back, I'll talk to you about that on another occasion.
Okay.
But you'll have to give me cookies.
Oh, yes. Oh, yes. I remember that. Something may arrive at your church.
Well,
Okay.
so everyone, thank you very much for joining us for this discussion today. Honest to goodness, Pam, we've just been honored to have you. Thank you so much.
My absolute pleasure. The honor is mine.
Thank you.
So, good night, everybody.
Bye.
Good night. Thank you.
Good night, all.
Good
Bye.
night.
All right.